This video is about basic operations in polar form. So let's start with a complex number Z1 expressed in polar modulus argument form, 5 cis pi on theta, 6, and our second complex number Z2 is 3 cis 3 pi on 4. The addition of them would be, converting back to the Cartesian or rectangular form, cos pi on 6 plus I sine pi on 6 plus 3 times cos 3 pi on 4 plus I sine 3 pi on 4. Okay, cos pi on 6 from the exact ratio, so that's going to be root 3 on 2, and sine pi on 6 times the factor of 5 as well will be 5 on 2 times I. Now, cos in the 3 pi on 4 is in the second quadrant, cos is negative there, and so we have minus 3 on root 2 because the factor 3 out front. And then for sine 3 pi on 4, we've got a 1 on root 2, but factor 3 out front, so we have 3 on root 2. All right, collecting the imaginary and real parts together appropriately. The imaginary parts give us over here an expression with a rational denominator, but a surd in the numerator. Surds in the numerator for the real part as well, but a rational denominator. Okay, and that's so back here we are in rectangular or Cartesian form. Okay, now we've seen that we can write Z as R, the modulus absolute value of the complex number, absolute value, times cis theta. Okay, argument form, modulus argument form. But we can also write cis theta as e, the exponent e, to the power of I times theta. All right, and that's the same as cos theta plus I sine theta. And then we have the absolute value or modulus of the complex number out front, the R value, the radial value. That's useful now because that's going to make our life multiplying a little bit easier. Okay, so let's have a look at multiplying Z1 and Z2 together. That's R1 e to the I theta 1 times R2 e to the I theta 2. All right, we can factor out the R1 and R2, the modulus of the two complex numbers. All right, and then what we can do with the exponents is we can add them, the same base e here, so we add those, factor out the complex number I, and we have in parentheses theta 1 plus theta 2. So Z1, Z2 multiplied together is R1 times R2 times e to the I theta 1 plus theta 2 together. Okay, or Z1, Z2 is R1 times R2 times cis of theta 1, converting back from exponential form back to cis theta form, we have R1 times R2 times cis theta 1 plus theta 2. So multiplying two complex numbers is simply adding the arguments, adding the angles. All right, for Z1, Z2, 5 cis pi on 6 times 3 cis 3 pi on 4. Right, multiply the 5 and the 3 together. That's the two absolute values, the moduluses of the complex numbers out front, and simply add the angles pi on 6 plus 3 pi on 4. We're left with 15 cis 11 pi on 12. And you notice 11 pi on 12 is just under pi, so it's in that positive range 0 to plus pi. If it was over pi into the third and fourth quadrants, then we'd have to use the negative form of the argument. Okay. The reciprocal of a complex number, so cis theta form, 1 over cis theta form, 1 over e to the I. Well, of course, when we take the index upstairs, express it in standard form up with the exponential up the top, then we have e to the negative of the argument minus I theta, and that's just cis minus theta. Okay, so simply taking the reciprocal just means we change the sign of the angle in the cis theta form. Okay, just an example, Z1, Z2 is R1 e to the I theta 1 over R2 e to the I theta 2. That's going to be R1 over R2 times e to the I theta 1 times E2. Bringing that exponent upstairs, we have the argument becomes negative, e to the minus I theta 2. Okay, which is R1 and R2 times E. We can combine by adding the powers together, so we get e to the I, and then in parentheses theta 1 minus theta 2. And coming back to cis theta form, that's R1 and R2 times cis theta 1 minus theta 2. So division just results in subtracting the angles in the same way that multiplication resulted in adding the angles. So thinking of the two examples we had at the top of the page, Z1 and Z2, we have R1 cis theta 1, R2 cis theta 2. This is the division of them. R1 and R2 cis theta 1 minus theta 2, 5 on 3. Remember from above earlier, cis pi on 6 minus 3 pi on 4, 5 on 3, sorry, times cis minus 7 pi on 12. And again, that's in that 0 to minus pi range. Okay, let's just have a look. Geometrical significance of multiplication. Well, we have Z1 and Z2. Okay, modulus R1, modulus R2, theta 1, theta 2. Okay, just summing them. All we've done is multiplied the two modulus together. Okay, multiplied and summed the arguments. So we've got theta 1 plus theta 2. Okay. If we had Z1 times Z1, so if we had Z1 times Z1, then all that would result is a doubling of the angle, and we would have R1 would be increased by a factor of R1, and we would have cis 2 theta. Okay, if we had Z1 times itself, then all we'd be doing with Z1 is we'd be increasing the angle, we'd be doubling the angle, and we'd be increasing R1 by a factor of R1. That would be the geometrical significance. So it would be an enlargement. Okay, an enlargement. All right, that's it.